Tomorrow we discuss the second distribution Weibull. Weibull spelling માં હોય કા Weibull distribution. Weibull distribution. This distribution is found by Weibull and it is a continuous distribution. What is distribution? Weibull distribution, that is a provided density function. How to write definition? What is definition? A continuous random variable capital X is said to follow Weibull distribution with parameter what is the parameter? Alpha lambda and its probability density function. What is PDF means probability density function is given by that is f of x equal to 2 alpha lambda x raised to alpha minus 1 e raised to minus lambda x raised to alpha, and x is positive, x is greater than or equal to 0, alpha and lambda is also positive, and 0 otherwise means this, otherwise negative values, otherwise, that is OW, otherwise. That is the probability density function of Weibull distribution. Then its graph, that is a sketch of this. We put that is x equal to 0. We take x-axis, y-axis. X-axis, take the values of x-axis, and y-axis we take the values of f of x probability density function. X equal to 0, this goes to the 0. Then x equal to 1, 2, 3 and lambda, put these values. X equal to 1, that is 1 minus 1, that is a 0, power is 0, that is a 1. Here is also, that is e raised to minus lambda 1. And some multiple factor, and this is increasing. X equal to infinity, 1 happened, that is also goes to decreasing. Put the lambda equal to 1, 2 and 3. This graph is also this. Okay. This graph is this type. That is the Weibull distribution sketch of this chapter. That is Weibull distribution. And then cumulative distribution function of this. Cumulative distribution function. CDF. Cumulative distribution function. That is also only distribution function. CDF. What is the notation? F of x equal to definition. Probability of x is less than or equal to x. That is equal to 0 to x, f of t dt. T is the dummy variable of x. T is the dummy variable of x. And what is the probability density function? F of x equal to lambda, alpha lambda, x raised to alpha minus 1, e raised to minus lambda, x raised to alpha, x is greater than or equal to 0, alpha lambda is positive, and 0 otherwise. 0 otherwise. Then put this t here, that is a t raised to alpha minus 1, e raised to minus t raised to alpha. That is equal to 0 to x alpha lambda t raised to alpha minus 1 e raised to minus lambda t raised to alpha dt. T is the dummy variable of x. Then simplify this. How to simplify? Put this lambda t raised to alpha equal to 1. Put y equal to lambda t raised to alpha. Okay. Differentiate with respect to t. That is a dy y dt lambda alpha. Alpha is this t raised to alpha minus 1 dt. That is the derivative of y equal to lambda t raised to alpha with respect to t. dy is this function, this and this. Sorry, this and this function, not this. Okay. Alpha t, alpha lambda t raised to alpha minus 1 dt, this dt is equal to dy. Substitute here. Range next, that is a dt and e raised to this is equal to 1 minus 1. Then here is a dy. Range, put here range 0, then y is equal to 0. Range is important. Y t equal to 0, y equal to also 0. T equal to x, therefore y is equal to lambda x raised to alpha. Then range 0 to lambda x raised to alpha. Then integrate this. Integration of this part is e raised to minus y divided by minus 1. Range 0 to lambda x raised to alpha. Okay. Then substitute upper limit and lower limit. Upper limit and lower limit. That is equal to, first substitute upper limit, that is equal to minus e raised to minus lambda x raised to alpha. There is minus e raised to 0 divided by minus 1. Divided by minus 1. This minus minus 1, e raised to 0 is 1, minus minus plus 1 minus e raised to minus lambda x raised to alpha. Range x is greater than or equal to 0. Otherwise, PDF is 0. Then find the distribution function. It's a distribution function. Similarly goes f of x is equal to 0 to x. Range 0 to x. F of t dt. X is otherwise means 0 to tan minus infinity to 0. Minus infinity to 0 and otherwise range tan f of t dt plus 0 to x f of t dt. Okay, otherwise, but here 0 to infinity. Here 0 to infinity, you write here 0 to infinity. That is equal to, already you have seen 0 to x. Okay, this PDF, otherwise PDF is 0 plus 0 to infinity alpha lambda x raised to alpha minus 1 e raised to minus lambda x raised to alpha. With respect to, there is a t dt, here is also t dt. Integrate this 0 to infinity. Okay, substitution all values and find out. That is a substitution, put y equal to lambda t raised to alpha, dy equal to alpha lambda t raised to alpha minus 1 dt. Okay, this is given. This value and this value is equal to dy e raised to minus y. Range similarly 0 to infinity. Substitution 0 to infinity. This value is goes to 0 plus e raised to minus y dy. Integrate this. E raised to minus y divided by minus 1, 0 to infinity. E raised to infinity 0. E raised to 0 divided by minus 1. This is a 1, that is minus minus plus 1, we get 1. Then distribution function, otherwise that is equal to 1, otherwise 1. Then this is the distribution function. Okay, this is a distribution function. Then for distribution function, we find the probability density function. If you given that differentiate with respect to x, we get probability density function. That is f dash x is equal to f of x. Derivative with respect to derivative. One derivative 0 minus derivative of that e raised to minus lambda x raised to alpha, and derivative of that minus alpha lambda x raised to alpha minus 1. Okay, minus minus plus alpha lambda x raised to alpha minus 1 e raised to minus lambda x raised to alpha x is greater or equal to 0. That is this. And derivative of that is 0. That is the probability density function. We get probability density function of this, and probability density function we get probability distribution function. Okay. Second, mean and variance. Mean and variance. Mean and variance of Weibull distribution. Mean and variance. The probability density function is f of x equal to alpha lambda x raised to alpha minus 1 e raised to minus lambda x raised to alpha x is greater than or equal to 0. Alpha lambda is positive and 0 otherwise. What is the definition of mean? Mean equal to expected value of x. How to find expected value of x? That is definition, integration 0 to infinity x f of x dx. What is f of x? F of x is this. Substitution, that is equal to 0 to infinity x alpha lambda x raised to alpha minus 1 and e raised to minus lambda x raised to alpha with respect to dx. Again, we solve this integration. Substitute alpha x raised to lambda x raised to alpha equal to 1. Put y equal to alpha x raised to lambda x raised to alpha. Differentiate with respect to again x. dy equal to alpha lambda x raised to alpha minus 1 dx. This is alpha lambda x raised to alpha minus 1 dx is equal to dy, and this power equal to 1. And range is again range. If x is greater than or equal to 0, therefore y is also, substitute y equal to 0 and x is equal to infinity, we get infinity value. That is equal to, range is 0 to infinity. 0 to infinity. X value. Here y equal to lambda x raised to alpha. Okay. X raised to alpha equal to y upon lambda. Then x equal to power divided 1 upon alpha, that is y upon lambda raised to 1 upon alpha. That is y raised to 1 upon alpha divided by lambda raised to 1 upon alpha. That is equal to. Substitute here. What is this? Y raised to 1 upon alpha. Lambda raised to 1 upon lambda raised to 1 upon alpha. Integration. This function is equal to d1 and e raised to minus 1. This function is equal to e raised to 1. Okay. This converted to gamma distribution. Convert to gamma distribution. How to convert? That is 1 upon lambda raised to 1 upon alpha. 0 to infinity y raised to 1 upon alpha plus 1 minus 1 e raised to minus 1 dy minus 1. Then this function goes to gamma distribution. This function goes to gamma distribution. Therefore, mean equal to 1 upon lambda raised to 1 upon alpha. Gamma 1 upon alpha plus 1. Okay. If you solve this factorial 1 upon alpha factorial, 1 by 1 converted, how to say gamma alpha plus n plus 1, n असेल तर काय येणार n minus 1 factorial. Okay, converted. If you converted gamma, how to convert it? 1 upon alpha raised to 1 upon alpha, 1 upon alpha, gamma, 1 upon alpha. 1 by 1 converted. That is the mean of the Weibull distribution. Then how to find variance? Variance. What is the variance definition? Variance of x. Definition of variance of x. Expected value of x square minus expected value of x bracket square. We are already finding expected value of x. What is expected value of x? We are finding 1 upon lambda raised to 1 upon alpha, gamma alpha plus 1 is this. That is equal. We find expected value of x square. What is expected value of x square definition? Definition is 0 to infinity x square f of x dx. Again substitute PDF of this. That is equal to 0 to infinity x square alpha lambda x raised to alpha minus 1 e raised to minus lambda x raised to alpha with respect to dx. Okay. Again substitute lambda x raised to alpha, that is y equal to lambda x raised to alpha. dy equal to alpha, differentiate with respect to x, alpha lambda x raised to alpha minus 1 with respect to dx. Range same again. X equal to this value. Okay, this substitution is equal to dy and e raised to minus y. That is x square is there. 0 to infinity. X square y raised to 2 upon alpha and 1 upon lambda raised to 2 upon alpha. 2 upon alpha. 2 upon e raised to minus y with respect to dy. X square this quantity, that is a bracket square, give this 2 upon alpha and 2 upon alpha. Okay. Then again converted to gamma distribution. 1 upon lambda raised to 2 upon alpha, 0 to infinity y raised to 2 upon alpha plus 1 minus 1 e raised to minus 1. This is converted to gamma distribution. That is this is n minus 1 e raised to minus 1. Okay. What is the value of that? One upon lambda raised to power 2 upon alpha. This is a gamma 2 upon alpha plus 1. Okay. This is the expected value of x square. Substitute expected value of x square here. Expected value of x square here. That is equal to 1 upon lambda raised to power 2 upon alpha gamma 2 upon alpha plus 1. This is expected value of x minus. What is the minus? Expected value of x. What is expected value of x? 1 upon lambda raised to 1 upon alpha gamma alpha 1 upon alpha plus 1 whole brackets are square. whole bracket the square. That is equal to 1 upon lambda 2 upon alpha gamma 2 upon alpha plus 1 minus 1 upon lambda raised to 2 upon alpha gamma 1 upon alpha plus 1 bracket raised to square. That is the square. 1 upon lambda raised to power 2 upon alpha common, that is equal to 1 upon lambda raised to 2 upon alpha inside the bracket gamma 2 upon alpha plus 1 minus gamma 1 upon alpha plus 1 bracket square and bracket complete. That is the variance of the distribution. Substitute lambda equal to alpha equal to some values. If alpha equal to 1, lambda equal to 1, what happened? This is 1. 2 plus 1, that is gamma 3 minus 2 bracket gamma 2 brackets are square. That is what is alpha equal to lambda equal to 1. What happened? काय होईल? What happened? Variance of x equal to 1 upon 1 bracket raised to 2 upon 1 bracket gamma 2 upon 1, that is a plus 1 minus gamma 1 upon 1 plus 1 brackets are square. This is a 1. 2 upon 1, that is a gamma 3 minus 1 upon 1 gamma 2 bracket square.
2.
It is a 2. Gamma, that is a 2 factorial. Okay. 1 factorial bracket square. That is equal to 2 factorial is 2. 1 factorial is 1. That is equal to 1. That is the standard exponential distribution variance. Mean is also 1. What is mean? What is the mean? 1 upon lambda raised to 1 upon alpha gamma 1 upon alpha plus 1. Substitution 1. This is a 1 value. 1 upon 1 1. 1 upon 1 1. Gamma 2. 2 is that is 1 factorial. We get 1. Mean is also 1. That is the standard exponential distribution. Mean and variance is 1. Standard exponential distribution. Particular cases of exponential distribution is a particular case of Weibull distribution. If alpha equal to 1, put alpha equal to 1. Alpha equal to 1, we get f of x is equal to lambda x raised to 1 minus 1 e raised to minus lambda x is equal to 0. That is equal to lambda e raised to minus lambda x is greater than or equal to 0. Which is a particular case of exponential distribution. This distribution x follows exponential distribution with parameter lambda. If lambda again 1, put lambda is again 1. That is f of x is equal to 1 into e raised to minus 1. X is greater than or equal to 0. That is x. E raised to minus x is greater than or equal to 0. Which is standard exponential distribution.